This is the second, this video is going to cover the second test of the mean. So let's just go directly to it. So if we look at this problem, we see that we have a tax return company claims that the mean simple tax return check of its clients is more than $643. A random sample of 36 clients yielded a mean of $661 with a standard deviation of $54. Test the claim at the alpha equals 0.05 level. I've highlighted claim information here and in yellow, and highlighted sample information in blue or turquoise. And so the claim alpha is 0.05, and the claim is that the mean is more than 643. So it's mu greater than 643, making it a right-tailed test. So we see then that the alternate hypothesis is mu greater than 643. I'm kind of skipping over this information here in step one because we covered that at length in the test of this, or in the structure videos. And the information in the sample gives us 36, the sample size, and 661, the sample mean, and 54, the sample standard deviation. So we need that information for the test statistic. Test statistic is T because it's a test of the mean. And we substitute the numbers in, including the mu or H0 value for mu, the 643, the assumed value, and we get 2.000, basically just flat out 2 as our test statistic value. So that's pretty simple, easy to remember. And the next thing we need to do, and what we need to do at this point, is determine if that test statistic value is unlikely or not. And we'll use either the critical value approach or the p-value approach. So let's look at the critical value approach first. This is a right-tailed test. So what we need is one critical value on the right, and table A3 is going to give that to us. We're going to look in the area in one tail and in the alpha column, once we find alpha in area in one tail, and the degrees of freedom row to get our test statistic. And let's take a peek at this, and let's go look at, well, actually, I do need to continue on with this. Sorry, it's already in here. I've attached it to okay, so here is our alpha was 0.05, and here's our table A3, and it's a right-tailed test. So it's area in one tail. So I'm in area in one tail. I look for alpha. Alpha is right here, 0.05, and that is at the head of the column of test statistics that we're going to use. So we're looking in this column, and we're going to go down to the we're going to go down to the degrees of freedom row, and I got to go back up to the top and look at my again 36. So I'm going to be looking in the 35 row. Okay, so let's go down to 35, and remember we're in this column right here. So the test statistic critical value for this test is 1.690. And no, it's not. 1.690 is the positive critical value, as if it were and it is, I'm sorry, it is a right-tailed test. So yes, 1.690 is the critical value for this one because it's on the right. Remember, this table only gives us positive critical value. So if we need one that is negative for a left tail test, or if we're dealing with two tails and we want the left side critical value, we would use the opposite. We would change the sign. But here it is a test, a right tail test, and our right critical value is going to be 1.690. So let's go back up to our problem. And remember what we're doing here. We've got our test statistic and we've got our critical value. We would plot the critical value, and then we would plot the test statistic to see if it falls farther from the mean than the critical value on that side. And it does. 2 is larger than positive 1.690, which means that the test statistic 2 is an unlikely value, and it's going to cause us to reject the null hypothesis. So again, for a greater than right tail test where H1 relationship is greater than, we look in the area in one tail, find alpha, go down that column to the degrees of freedom row, and that is going to be our critical value. So now let's look at the p-value approach. And remember what we're doing in the p-value. We're finding the probability that the test statistic takes on values more extreme, which means farther from the mean than the test statistic. And this is a one-tailed test, so we're just going to plot the test statistic, find the area underneath the curve farther away from the test statistic, in this case on the right side. So this is what we're looking at here. And we want to find this area, and that will be the p-value. So for a right tail test, we'll input the lower bound as the test statistic, the upper bound as a large positive value of t, and we'll enter the degrees of freedom. Again, this is going to be 35. And so we're going to start out with 2.000 right here, and we're going to go all the way up to a large positive number, which in this case, we're going to use 9999. So I'm going to do this on the calculator. So let's go look at the calculator. Let me quit out of here. And we're going to go find the tcdf function, which is in second vars. All of these CDF functions that we're using to find probabilities for the p-value are going to be under second vars. Ours is number 6, tcdf. And remember, we're going to use the test statistic, which is 2.0000. So I'm just going to put 2 in there. And then we're going to put in a large positive number, the upper bound, and comma, and the degrees of freedom, which is 35, close parentheses, and hit enter. And we get a p-value of 0.0267, okay? Rounded to 4 decimal places, 0.0267. Let's go back to the document. And that's 0.0267, and that's what this shows us. So I guess I did it right this time. And then once we have our p-value, we remember what we're going to do is compare it to alpha. And we will only reject the null hypothesis if the p-value is less than or equal to alpha. And in this case, it is. So we're going to reject 0. From the critical value approach, we found that the test statistic was farther from the mean than the critical value on the right. It was bigger than 1.690. And we found that the p-value was less than or equal to 0.05, the significance level. Therefore, we're going to reject 0. And then we will use the flow chart or the table in the 8.2 structure of hypothesis testing document. Either one is going to give us the correct wording for the conclusion. Okay, Now, I've also done the calculator test, a hypothesis test for mean on the calculator. Again, it's under stat, right arrow tests, and it's number 2, the t-test. We need to put in the correct numbers here. The null hypothesis value was 643. And the X bar was 661, and S was 54, and N was 36. So I'm going to go to the calculator and clear that out. And let's do stat, right arrow to tests, and number 2. And then let's go down to 643 was the 80 value. 661 was the sample mean. I think it was 48 for the sample standard deviation. And 31. 36, sorry, 54, not 48, 54 and 36. So let's go up there, 54 and 36. And this was a right tail test. So I move over there and highlight that. I'm going to go ahead and do the curve, draw the p-value curve. And we see the area underneath the curve to the right of the test statistic, which was 2, was 0.0267. All right, so let's, that concludes then our discussion of the second problem. And we'll continue on with the third problem in the next video.